recording from this point on, so let me go to Zoom, share screen, and I don't want my email. That's not what I'm looking for. So let me go through and minimize that. Okay.
I have one question.
Okay.
What is TR on the days? What does TR mean?
Tuesday, Thursday.
Okay, Tuesday, Thursday.
Yeah. That must be this new banner. I like TTH. To me, that's a lot clearer.
Yeah.
But let's see.
What about TBA?
That means to be announced. That shouldn't be on there. What course is that?
That is for differential equations.
Really? This course?
Yeah. When I took the screenshot, which was yesterday, he said it's bird.
Oh, you know what that was? Here's what happened there. You probably weren't on at the very first of the class. It was just Kara and I were the only two on there at the time. What happened was they canceled my Cal 2 and differential equations. We had an emergency meeting with the dean Friday afternoon from 4 to almost 6 o'clock. Went through the whole schedule. She didn't say a thing about canceling these classes. I had talked with the associate dean before that meeting, and he was good with my schedule. Everything was fine. Nothing was said about canceling this class, and that's what the main purpose of that meeting was. Went right through it, no issue. And then, yesterday afternoon, when I went to start setting up the class and stuff like that, it wasn't there. Well, it was my Cal 2, because that was the one that met this morning. I couldn't see it anywhere. I couldn't get it. And I thought, what's going on here? It wasn't on my blackboard. So I emailed the dean, and she got all upset. And then she said, oh, and she said, your name is on it, isn't it? And I looked then and saw that it had been canceled. I said, well, it was on it Friday when we met, but now it's not anymore. Evidently the course has been canceled. And the students needed to graduate and that kind of stuff. And she said, oh, well, we never canceled those. That must be an error, blah, 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 blah. And then ultimately she, I emailed and she emailed, everybody emailed different people on a Sunday afternoon to get it put back on, because I couldn't do anything on the syllabus. I couldn't do anything because I wasn't teaching the course anymore. So you must have looked at it then when it was after it had been removed, and then it was put back later. Okay, now I have to find out some way to get my go back. Okay, I didn't do that part. Okay, now go back to Zoom. Okay, there we are. All right, can you see my blackboard? Okay, good deal. All right, here we are, Math 238. That's the course number, applied differential equations. We'll open that up. Now, a lot of this is going to be just like what we talked about before. I can't remember when you came in. Let me move us out of the way. You're always in the way, Jesus, you know that. Okay, I'm going to move us up here. Okay, I'll probably have to move us again later, but you couldn't see what I was talking about. It says start here. Were you there for my last class when we started this part, or did you come in later?
I think I was I'm not sure, but I didn't do the start here.
Okay. Notice how it underlines. Sometimes when you click on an underline, it'll open. Other times it won't. This time it won't. Notice here, it doesn't open. So what you have to do then is come over. First try the down arrow. That's an expand start here. And this is all that's there. Your first task is to familiarize yourself with the course. Start here to get to know your online course. This isn't an online course, it's a virtual course. Be sure to complete your course syllabus agreement to be counted as be present in week 1. Well, that's for online students, not for virtual students. Online students, that's the only way they get to be counted present because they're never in class with the instructor. So that's for them. You don't have to do that, but they still like for you to do it. But for James, who's not here, if he's not here on Wednesday either for this class, then he's going to have to do that. Otherwise, I can't count him present for the course. Okay, so that's why they have that. It's sort of a hodgepodge thing that they've got. That's all that is. Okay, so I'm going to close that back. Okay, and then instructor contact and office hours. Okay, here's somebody calling me. This could be James. Let me see. Good afternoon, Charles Fowler speaking. Hello? Hello? Whoever it was did not answer. Okay. All right. So let's come down to instructor contact and office hours. Okay. You see that underlined again? Okay. Let me click on that. Nothing happens. So I have to come over here and do the down arrow. And then it says this, faculty, your preferred contact information, her, it's supposed to be here. I thought I had already done this, and I don't see that it's in here. Sorry about, oh no, here it is, here it is. Here's instructor. See, what's the difference in this and that? I can't figure it out. So this one, now you see it has a page by it. That means I can click on the underline here and that page will open. And here it is. Okay. Wow. I thought last night I filled all this stuff in. I wonder if I did my 237 class. Anyway, my name is Charles Fowler. Brief bio, all I've been putting here is that I'm mathematics instructor and math department chair, and I also teach physics and physical science classes. Okay? Email cfowler@lawsonstate.edu. You probably already know that. Preferred method of contact, email or Blackboard message, either one. I'll have to do that. And that's where you could schedule a virtual appointment with me using the Virtual Advising Center. Or you could choose me or any advisor. And best hours to reach the instructor, and this is, I'll just tell it to you. I thought I had filled this in last night, but I must have missed it. Okay, best hours to reach me would be 8 to 10 on Monday or Wednesday morning. Okay, and we'll talk about this later too. 8 to 10 on most Mondays, that's all I've got is office hours. On Wednesdays, however, I'm also down to be a virtual advisor from 8 to 9 on Wednesday morning. So if you can't catch me at 8 to 9 on Wednesday morning, it may be because I'm with an advisee, okay, because we have to sign up for 5 hours a week. So that's that. Okay, then from 10 o'clock I have my Cal 2 class, 12:15 I have Cal 3 class, and then at 2:30 I have this class, and there's only 15-20 minutes between those other classes. So then I'm sorry, 30 to 35 minutes between the other classes. And then, but then at 4 o'clock, this class gets through at 3:45. From 4 o'clock till 6 o'clock, I'm free on Mondays and Wednesdays. However, that's where I put my next 2 hours. We're required to do 5 hours of virtual advising. So my first hour is Monday afternoon from 5 to 6. The second hour is Wednesday morning, 8 to 9. The third hour is Wednesday afternoon, 5 to 6. And the last 2 hours are Friday morning, 8 to 10. Now, you don't always have students sign up, so most of the time I'm just doing regular advising. So you can contact me, but if I don't answer during those times, 5 to 6 Monday or Wednesday afternoon, 8 to 9 Wednesday morning, or 8 to 10 Friday morning, the odds are that I'm busy with an advisee. Okay, so that's probably what's going on there. So those are the best hours to reach me. except for those advising hours. And I'm not going to do a video. So I swear I thought I did this last night, but it's not showing up. Okay. That's my contact information. Okay. Weekly assignment and activities. Now again, there's no page here, but if you click on this, nothing happens. So I go to the down arrow here, and this module contains a to-do list, weekly assignments, and assessments, resources, and supplementary materials. So let's do week 1. If you click on the underline, because this is a folder now, it should open. Okay, whoops, I closed it by mistake. Okay, overview and weekly to-do list. Click on that because it has a page next to it. And there it is. Okay, this part I filled in. I don't know where the rest of it is. This week we'll go over the course syllabus. That's what we're doing now. Research paper instructions, we're going to do that, but you've already heard it today. My locator card, you've already seen that today. How the course will be conducted, we will talk about that. And we'll start in chapter 1, section 1.1. Okay, so we'll probably get started about like we did in the other class, maybe 5 minutes at the end, if we get that much, because we've already lost some time. And this is only an hour and 15 minutes. The other one's hour 40 minutes, so we may not get there. Classes will meet each Monday, Wednesday at 2:30 via Zoom. I'll post the Zoom invite the day before each class as a Blackboard announcement. That's where you'll find out. Of course, you know that because you're here. We'll learn about what we're going to be covering in 1.1, definitions and terminology used in differential equations. So what are our objectives? Review the course syllabus, review the research paper instructions, review how Blackboard is organized to assist you as a student, review my office hours and availability. I just told them to you, but they didn't show up on the place where I wanted them to be. And I'll introduce to you definitions and terminology used in differential equations. All right, weekly to-do list. Review the syllabus, that's what we're doing. Well, we're not in the syllabus yet, but we will be. And complete the course syllabus agreement, same as last time. This rather part is mostly for online courses, but you can do it if you want to. Review the research paper instructions, which we already have done, and submit your first proposed research paper topic. Now, what I mean by that is you can change it. It's not that you have multiple research papers, it's just your first guess of what you want to write on, okay? And then the other to-do thing is read chapter 1, section 1.1, and this is on pages 2 through 11. Okay, now that's the overview. Here's the specifics, I think. Now, okay. Seems like to me we haven't hit the syllabus yet. Where in the world was that?
Was it in the top?
I know. Yeah, we didn't go over it. There it is. Start here, syllabus. I didn't see it. Let's go back and open it. See, it's not coming up. Here we are. Okay. It took a couple of clicks before it would open. Okay, navigating the course for online learning tips. That's mostly for online classes, so don't sweat that. Here's the course syllabus. I'm going to click here. See, it has a page by it, so I'll click there. And here's the syllabus right here. Notice this doesn't underline. Even though there's a page there, it doesn't underline, so you have to come to the 3 dots to get it to open. So if you click on the 3 dots, hopefully, oh yeah, all it says is download original file. Okay, so there, I'll download it, and it has to wait until all of them down. There it goes. So now I'll open it lower left corner. Click on that, and here's slow syllabus. All right, now the screen sharing stops, so I have to go to a new share, and the new share will be the syllabus. Here it is right there. All right. Now, I don't know if you came in here. You were. Okay, but this is for this course, not the other one. This course is an introduction to techniques in solving differential equations with applications. Topics include solving first-order differential equations. Okay, I'm going to pause right here. Okay, that's basically chapter 2. Okay, applications to various models. Okay, that's going to be in 1.3. Okay, so that's why we do chapter 1. Solving higher order linear differential equations. That's chapter 4, higher order differential equations. Okay, with constant coefficients, and that includes a general theory, undetermined coefficients, reduction of order, and methods of variation of parameters, and the Laplace transform. Series solutions and solutions to systems are also covered. Well, that last part, I remember I said was chapter 4. That's usually just about where we get. Chapter 6 is series solutions, and chapter 7 is Laplace transform. So far, I haven't made it into those 2 chapters yet, because just about the entire time that chapter 2 is a huge chapter and chapter 4 is a huge chapter. So we're going to do chapter 1. It's not going to take too long. Chapter 2 will be the second test, and chapter 4 will be the third test. If we have time at the end, then we'll try to do a little bit with series solutions and Laplace transforms, but the odds are that may be as far as we get. Okay, so we'll get most of those done. It's just this last sentence here we may not get to. Well, that last phrase in the previous sentence, Laplace transforms, and that. Okay, and here's one reason. Even though I was on the committee that went through this, they were insistent on including that. But when I was an undergraduate, we didn't get to Laplace transforms until either a 300 or 400 level course. In other words, junior or senior level. So I don't see why or how they put it in to a sophomore level course. You know, it just doesn't seem right. It was its own course back when I was in school. Of course, a lot of things have changed. Okay, prerequisites supposed to be in Math 227. You and James both got in on co-requisite. And if Kara comes in, that will be, and also Laron. Okay, here's a textbook. It is required a first course in differential equations with modeling applications. Now it happens to be, and this is going to be a little bit of this distraction here, but I'm going to show you what the cover of that book looks like. Right there. Okay. First course in differential equations with modeling applications, 11th edition. Can you see that on your screen?
Yes.
Okay. Yeah, the astronaut on the spacewalk, and Dennis Zill is the author, and you can't see much of the other stuff. But when I was teaching it this summer, one of the students said, yeah, Auburn, they let us share the things because this book doesn't have PowerPoints. So we'll actually be using the chapters. I'll open up chapter 1 and we will be using that rather than PowerPoint. So that's why I have this here. Okay, so let's go back to the syllabus. Okay. So that's what the books looks like. First course of differential equation modeling applications, 11th edition, Dennis Zill. It's a Cengage book, 2018, meaning it's only probably got a year or 2 left of life in it, but you don't care, you'll be through with it. Okay, graphing calculator, yeah, it's not really necessary in this course, but it might be useful to have. We will be doing some fairly hefty calculations at a couple of points, and the fancier the calculator, the easier that'll be probably. Okay, You will need paper, graph paper, pencils, though you can use pen if you want to. The rest of this is that stinking advertisement for Cengage, which I can't stand, but they make us put it in here. So I'm going to scroll through that. So you see it's same price. You can get your calculus book, though you probably already have that, and this book too for that same cost. Okay. Get through all that, and here's where the syllabus picks up again. Here are the course objectives. By the end of the course, you'll be able to distinguish types and solutions of differential equations. Well, that types part, that's what we're going to be doing first. Definitions and terminology. What are your different types of differential equations? Also, initial value problems rather than boundary, general problems, okay, and boundary value problems. So that's sort of covered in that. Analyze first order differential equations, that's chapter 2. Solve mathematical models involving ordinary differential equations. We'll do a little bit of that, but that's going to be 1.3 mostly. Less solving than just talking about it. Okay, classify and solve higher order linear differential equations. That's chapter 4. Okay, and then solve initial value problems using Laplace transforms. We'll try to get there, but that's chapter 7. Now notice in this one they didn't say anything about series solution. Don't know why they had it in the first part but not in the second part. Okay, required topics, definitions and terminology. That's section 1.1. Differential equations as models, that's section 1.3. First order differential equations, that's basically chapter 2. Separable equations, that's 2.2. Exact equations is 2.4. Linear equations using integrating factor, that's 2.3. Solutions by substitutions, that's 2.5, and systems of linear and nonlinear equations, that's not covered in chapter 2, that's in chapter 6, I think. No, that's series solutions. Where do they have systems? This book doesn't do systems per se. We'll probably be doing that kind of stuff as we go, but that's probably not something because our book doesn't have a section on that. Second and higher order differential equations, that's chapter 4. Okay, homogeneous and non-homogeneous equations, that's 4.1.2 and 4.1.3. Okay, reduction of order, that's 4.2. Homogeneous equations with constant coefficients, now that's a different kind of homogeneous, well no, that's the same, that's 4.3. Okay, undetermined coefficients, that's 4.4 or 4.5. We're going to do 4.4. I've taught both of those. I think students tend to like the 4.4 approach better. Okay, variation of parameters, that's 4.6. Okay, Cauchy or Cauchy, I don't know how to pronounce that, Euler equation, that's 4.7. And so far I have barely gotten into that. Systems of linear equations, that's 4.9. I'm sorry, I misstated before. That's 4.9. Nonlinear equations, that's 4.10. So far we haven't gotten there. The spring mass systems, that's 5.1.1, 2, and 3. Okay, and so far I haven't made it into that one either. Linear systems with boundary value problems, okay, that goes back to well, they don't have a section covering it. Oh, there it is, 4.8.2. Okay, though we're going to hit it before we get that far. Okay, and then nonlinear equations, the numerical solution, there's a little bit of that touched in 2.6. Okay, and nonlinear equations also shows up in 4.10, which we've already mentioned. Okay, power series solutions, that's chapter 6 basically, 6.1. Okay, solutions about ordinary points, that's 6.2, about singular points, 6.3. So far I've never made it there. Laplace transforms, that's basically chapter 7, and applications of the Laplace transforms, that's also chapter 7, though they don't have a special topic naming that. Okay. The rest of chapter 7 is dealing with that. Okay, I think that's just about it. So you see, there's a lot here. Okay, optional topics, step functions, I know we're not going to get there. Discontinuous forcing functions, we won't get there. And impulse functions, we won't get there. Okay, evaluation and assessment, just like I said before, your research paper is a required grade. Okay, so, and we've already talked about that. We'll have one for this class too. I know you're delighted to hear that you will have 2 this term. Okay, and if you want to take linear algebra, you can have a 3rd one. Okay, but that's the required score. The very last test, which basically is going to be more than likely your chapter 4 test, that will also be a required grade. The chapters 1 and 2, you can do the drop the lowest of those 2 scores. Okay, and then I'll do the average of those. Your research paper, your highest chapter 1 or 2, and then chapter 4, and that's going to be average of those 3 will be your final average. Attendance is exactly like it was in the last one. This part is from the state, this part is from Lawson. Okay. Description of statement on discrimination and harassment. Have a hard time figuring out how you have that on a virtual environment, but if you do, please let me know. If you sense it's happening to you yourself or anybody else, please let us know, because we don't want it happening here. Okay, Americans with Disability, and this is from the state, it's also our policy too, and Americans with Disability, this is from the state, this part, and this part down here is Lawson, specifically Lawson. It gives Dr. Renee Herndon's phone number and Ms. Janine McCoy Jones, and also gives our website there. Okay, and what tabs? Click on the blue Student Services blue tab, and then Disability Services link, and meet and contact your ADA counselors there. Okay, now here is your acknowledgement page, and that's what you need to sign to turn in. And James, you're not here, and anyone else who may join the class later, I've got to have this from you if you're not going to be here either today or Wednesday. That's the only way I'll be able to count you as attending if you can't be here in person, you might say. Okay? Any questions on the syllabus? Okay. Then let's get out of the syllabus. There and there. Okay. And we'll move back to, I think this is it right here. Yep, that's it. So there's the syllabus. Now this part here is mostly, you can't see it, but I have a toolbar that's just right in the middle of the screen here. Not quite in the middle, but awfully close. And it blocks half of or a lot of what I want to see. Okay. Still haven't heard from James. This part down here is mostly for online courses. Okay. You're here, you're hearing it. You don't have to see what it looks like. You're there. Okay. So, again, the blue X over here that you don't see, that's how you go back to the previous slide. Okay. So there was the syllabus agreement. Again, that's mostly for online students. The textbook and other required course materials that was in the syllabus, it's going to be here too. There it is. There's the stuff that was in the syllabus and all that cheap advertisement that we do for Cengage. Okay. So you've seen that before, right? Twice before. Oh, except this is for this book. Okay. Now, that's the syllabus textbook stuff. The course weekly schedule. Again, we'll click on the underline there because it does have a page beside it. And this week, access and read through the course content. Weekly. Oh, this is for online students mostly. Okay. I'm not going to do that because they have to have their assignments in by Sunday evening in order to be counted present for the week. Okay. Require computing skills. That's mostly for online students. American Disability, 88. Same stuff we've seen before in a slightly different form. This is all Lawson here, and it just breaks it up and puts it in different emphasis. But it's the same material that we had before. Read that, pay attention to it. Okay. Again, there's so much duplication here in this, it's pathetic. Okay. Let's keep on going down here. I think that's the end of the start here part. No, that's the end of navigating part. Okay. Let's see if that also ends the start here part. Yes. Now we get into instructor contact and office hours information. Now, clicking on this won't do you any good because there's no page next to it, but it's already been opened. You'll see the up arrow here rather than down arrow. It just says update your preferred contact. I need to do that because they mistyped it. This drives me crazy. Does that block off anything you see here?
Not really.
Oh, really? Okay, good. I can't get rid of it. Okay. Here's instructor contact information. Oh, this is the one that I still have to fill out. Okay, sorry about that. We did go over this one, I thought, because I skipped too far down. Okay. And weekly assignments, we started there. We started there. We did the overview, didn't we? I've got to scroll up because that's in my way. Here's instructional materials, lessons, blah, 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 blah. Okay. Now, why did it do that? This has gone completely haywire. Okay, here we go. I don't know why it went to the roster. I was nowhere close to that. Okay. This is where we were. Click on that. Okay. I don't have any PowerPoint slides, but it just dawned on me. I'm going to put, remember I said the PDF version of the book? I'm going to put it right there. Well, let's see. Where else would I put it? I may put it under other materials down here. Where would you rather have it? Under PowerPoint slides or down here under etc. Or instructional videos? It's not really a video. It could be under handouts or it's not going to be a lab. Where would you want it? You get to choose. You're the only one here.
It doesn't matter.
Okay. Okay. I think so too, because that's most important. So I'll put it right there. Okay. They probably don't want it there, but I'm going to put it there. Okay. Now, recorded lectures. This first one is, I believe, talking about the syllabus and the first part of 1.1. And this is all 1.1, and this one is 1.1 and 1.2. Okay, so all these cover some portion of 1.1. Okay, here's the research paper general instructions. Do you want to see that again?
Sure.
Okay. Now notice it didn't, even though there's a page here, it didn't underline when I put this on. So that means we come over to the three dots and click, and it says download original file. I do. Wait for it to load. Now it's loaded, so let's open it again. Okay, while that's opening, I'm going to get a swig of water. All right. You probably can't see this. So let me go to a new share here and do research paper. All right, this is exactly the same thing you saw in the last course. Okay, everything's the same. Only this time it's talking about differential equations. So it's a different paper, okay? A different paper this time, anything dealing with differential equations, which there are tons of things out there, but all the guidance and information and instructions, they're all the same, okay? Pick your, yeah.
It can be about anything, just has to be mostly about differential equations.
Yes, anything that we cover in the book. For instance, remember that name I couldn't pronounce, Cauchy Euler. Okay, well, Cauchy Euler. You could write about who in the world is Cauchy, who in the world was Leonhard Euler. Remember we mentioned something about Laplace transforms. Who was Laplace? Or how in the world did Cauchy and Euler put together that theorem? Or yeah, I mean, it can be people, it can be theories, it can be applications, it can be just about anything. How do you use differential equations in what's your major? Electrical or electrical engineering? Hey, those Laplace transforms, in electrical engineering, you're going to run into those a lot, okay? Because that's a lot of what you're going to be, that's most of the people in the, when I took Laplace transform class at Georgia Tech, except for a few physics students like I was in there, most of the rest of the people in there were not math majors. They were electrical engineering graduate students. Okay, they were taking Laplace transforms. So you can write on who in the world Laplace is, how they use this, how do they use them in uh, electrical engineering, because we're not going to get that far. So if you want to look there. 7.5 in the table of contents talks about the Dirac delta function, which we're not going to go over, but Dirac was a person's name, believe it or not. That was a weird name, but that was his name. Who was he? That could be a paper topic. How did he develop or use these the Dirac delta functions? What are they used for? What do they use them for? There's all sorts of things up there at the top of that table of contents page. Green's function. Who in the world was Green? You know, we ran into him in Cal 3. So you can't write on him for both courses, but pick, if you want to write in this course, that would be fine. How did it deal with initial and boundary value problems? Or in the other course, how do you do with the integrals that we were using? I think that was in that last chapter in that one. So there's lots of different. Your book is a good source of ideas. Now, if you just want to write on something that's of interest to you that deals with some way with differential equations, go for it. Okay. In fact, when we do 1.3, which is applications of or mathematical models, one of those models is going to be disease. Okay, and you could write about the COVID virus if you wanted to, and how the differential equations help describe how that disease is progressing, you know. And when you hear people talking about flattening the curve, you're changing the, we'll talk about this in class. It's called I think a sigmoid curve, and it usually goes up very steep when the rates are going up incredibly fast. If you can flatten that out, that slows it down, and therefore you won't overrun your medical delivery system. And that's what they're talking about when the politicians or the people from CDC or wherever are talking about flattening the curve. That's what they're meaning. Okay, so there's all kinds of possibilities here for paper topics. Okay, all the general instructions are the same, at least one word process page of text, which is going to be 2 pieces of paper, remember? If you start typing here, you have all your header and everything here, then you type to the bottom of this page and then to the top of the next page, at least that far down. That's a page of text, okay? So don't forget that. I want it double space. This is single space, but the point or the font is, you can use any font you want to, but 12 pitch or 12-point font. And there's no penalty for it being too long. There is for it being too short. You have to have 1 or more sources. The more the better. Be sure you follow your formatting. Whichever one you go with, stay with it. If you start blocking paragraphs, block them off. You start indenting paragraphs, indent them all in the same method. Okay? Don't change fonts in the middle of a paper. That I've seen that happen. I don't know why. It's just lazy, not paying attention, I guess. And all the rest of the things we talked about before. Okay? Try to get it to me as early as you can. The earlier you can get bonus points. Later, fewer bonus points. Okay? If any. Okay? So all that still is applicable. Month of August is 4 bonus points, September 3, October 2, November 1. If you turn it in that first week in December, you just get your score. Anything after that first week in December, you start losing points. Okay, and be sure to attach a single page from one of your sources. Pick a source, any source, I don't care which source, and then print me or copy me or somehow attach a single page. Send me a separate email or whatever, but be sure you attach a page with that. All right. Any questions? Yeah.
The topic's different, you said, right?
Yeah, you can't. Yeah.
This is on class, and we gotta search it up, or you're gonna give us the options?
No, you pick your topic. I don't want to limit you to my imagination. You go with yours. Um,
Last class you gave us some topics, right?
no, I said the same thing. I just like I went through the book and said, here's a few just ideas, but that's just,
Oh, okay, gotcha.
yeah. Now, when you said same topic, in a sense, if you said applications of integration or triple integrals or partial derivatives or something like that in electrical engineering, that could be a paper in the other course, and applications of electrical engineering in differential equations, that could be. So sort of like the same topic, but they have to be different papers. That one's dealing with a topic in Cal 3. This is dealing with a topic in differential equations. Okay? So, I mean, I'm not giving you a title. I'm just saying if you did choose that, it could be the same type topic, but with different emphasis. Or it could be completely different. It doesn't matter. Okay. All right. Any other questions about the paper? Okay. So let's get through with that one. Okay. And let's go back to, I hope this is the syllabus. Yeah. Okay. All right. And my locator card is the same as it was before. You want to see it again?
Nah.
Okay. Because James and I guess everybody else is in it, there's no reason to do it because they saw it before too. But if anyone else new joins the course, I could come back and open that up again. Now, the other thing is probably somewhere here, probably under etc. here. I'll also put your link or whatever they call that class key or whatever it is for the WebAssign. Yeah, Cengage thing. Yeah, so you can access your ebook if you need it. Okay, so I'll probably put that in here too. The guy sent it to me late last week, but I didn't have a chance to put it in syllabus. Okay, so I'll try to get that done. Probably not today. Definitely not tomorrow. Maybe Wednesday morning. I'll try to get caught up with that. Okay, if not, it may be the weekend. Okay. All right, let's go back here. That was instructional materials, and this thing is right in my way again, so hold still. I've got to move it again and again and again. Okay, there we go. All right, that was that one. Textbook link here. That's basically to take you to the Lawson State web page, the bookstore link. That's what that is. You can go to it if you want. I see no special reason to show it to you now. Oh, yeah, okay. All right. We're not doing, unless you need me to or would like me to, a discussion group. We can do that in class since there's only 3 of us, 2 students and me. But if you want to have one that y'all can work on a project or problem outside of class, I can put one out there if you're interested. Okay, week 1 assignment. Let's go on and say, I think I put something here. Let me see if I can get it to open. Oops, no I didn't. I thought I did. It was late last night, so I must not have done that. Again, I'll try to have this ready by Wednesday. We've already talked about what those are. I thought I'd put them there too. Okay. And there's no assessment this week. How to submit an assignment in Blackboard. I think you know how to do that. You can either do it Blackboard message or you can do it through email. You don't have to use Blackboard. Okay. Additional blah, blah, blah. And then after that is the various other weeks. All right. Any questions on Blackboard, syllabus, research paper, locator card, any of the things we talked about? No. Okay. Well, then that sounds like we're ready to start class, doesn't it? How are we doing time-wise? We go until 3:45, don't we?
Yep.
Yeah. Okay. So we don't have about 15 minutes on this one, which is pretty good. Okay. So let's get out of this screen share and go to this one. There's your textbook. So we're going to start with chapter 1, 1.1. All right. Definitions and terminology. Okay. Now, again, I guess maybe we should have done this introduction first. Let's go back to that. Here we go. Can you see this? It indicates it's screen sharing. Okay. Now, I have just a little, and it's very minor, issue with how it's named, and that's because this stuff developed over time. It seems like to me, rather than a differential equation, you would almost want to call these derivative equations, because most of the time you're dealing with a derivative. The words differential and equations suggest some type of equation, and what an equation is anything with an equal sign, okay? And on one side of the equal sign, usually we have something with a derivative in it, not usually a differential, though some of these equations will be written in differential form. Now, I don't know if you remember the difference between derivatives and differentials, do you?
Derivatives and differentials.
Yeah.
Derivative is the I do remember we had
Okay.
it at the beginning of the summer.
Right. Let me see if I can write on this screen. I'm not sure that I can. Let me see. No, I can't write on this screen. Let's go to the whiteboard. All right. Now I need to move things around. You're in the way again, you know. Okay. And I also will move, let's see, actually I'm going to move us down here. Okay. And then I'm going to move this toolbar as far out of the way as I can up here. And then I'll move this as far as I can this way. I don't know, can you see me moving this around, or am I?
I just see white.
White, okay. All right, so here's what we're going to do on our white here. If I can get my pen to show up, it would help to use the right end of the pen. This to me is what I would call a derivative equation. dy dx is equal to 2x. That's a really simple derivative equation, but that's what we call a differential equation. To be a differential, you would write the same thing as dy is equal to 2x dx. This is differential form, that's derivative form. Now quite often we'll use the prime notation and just do this y prime is equal to 2x. Again, you're talking of a derivative, not a differential. But guess what? We're going to call any and all of those differential equations. Okay? Even though this is a derivative, not a differential, that's a differential. But both of these are differential. All three of these are differential equations. The equal sign makes it an equation. The fact that somewhere in that equation you have either a derivative here or a differential like that. That's what makes a differential equation. Okay. Just a nicky-picky little point. Okay. So let's go back to this. So the term differential equation suggests some type of equation that involves a derivative. They use the prime notation, and of course y double prime is a second derivative, y triple prime is a third derivative, all like that. Analogous to a course in algebra in which a good time is spent solving, this would be a quadratic equation. There's no derivative in it. That would be a quadratic equation because there's an equal sign. Okay, this on this side happens to be a quadratic form. Now, this we know probably is going to come up with some unknown value x. In fact, this probably will have two values x because it's a second degree polynomial equation. Okay, so in this course what we'll be doing is solving an equation that looks like this. Now, part of what we're going to talk about in definitions and terminology, which is 1.1, is what do we mean by this differential equation? What kind of differential equation is it? Well, first, it's second order differential equation. That means the maximum derivative is 2. This is a second degree polynomial equation because the maximum exponent was 2. Okay? Now, later we'll also call this a linear differential equation. Now that has nothing to do with this. It couldn't be called a linear polynomial equation because it's a quadratic. It's not linear. But we'll see there is a reason that's called linear. And the reason, well, we'll get into that later. So there's various things we can name them. So whereas here we found the unknown solution x for this equation, down here we're going to use the unknown function y that's going to solve this one. Okay, so y is going to be some unknown function. They use phi of x. Okay, why didn't they use alpha of x? There's no real reason. They just use phi. They sort of like using Greek letters rather than other letters. Okay, so that's what we're going to be looking for. The function y, which solves this differential equation, just like we looked for the number x that solved that polynomial equation. So as the course unfolds, you'll see there's more than one type of differential equations. We'll be looking at various ways to do it. So first we're going to start with, okay, what they say, in order to read, study, and be conversant with the subject, we'll need to learn the terminology first. And that's why 1.1 is definitions terminology. Okay. Then the middle section here is going to talk about initial value problems. And again, this is going to be from a terminology viewpoint, not from a how to solve them. Just what in the world do we mean by initial values? Okay. And then the third one is going to be the link between differential equations and the real world, and that's mathematical models for various things, and that's where disease models come from. Okay, so now we'll move into 1.1, definitions and terminology. I'm going to stop somewhere here because you're in the way again. Okay, there we go. Now, this is a derivative, dy dx, of a function. The function y, you could call it f of x, they call it phi of x. Maybe phi stands for f in Greek, I don't know. Okay, is itself another function. The derivative, if y is equal to phi of x, then dy dx would be phi prime of x. Now remember, there's so many ways you can talk about a derivative. Okay, now if that started off being an exponential function, y is equal to e to the 0.1 x squared. That's your exponent for the irrational number e. This is an exponential function that is differentiable over all real numbers, because exponential functions are differentiable everywhere. Okay, and you also would need a chain rule on it, because the derivative of an exponential function is the exponential function, but then the chain rule would be the innermost part, the derivative of this part. Okay, now if you did that very thing we just said, take the derivative of it, and I don't think we'll be able to do it on this screen. No, I can't write on this screen. So let's do that. Let's go to our whiteboard again. This is mostly a review of Cal 1. Okay, so there was our function. Y was equal to e to the, was it a, no, it wasn't a minus, 0.1 x squared. Okay, now if we take a derivative, dy dx, or y prime, however you want to call that, okay, derivative of the outer function, the exponential function, is itself. That's the beauty of an exponential function, e to the 0.1 x squared. But then the chain rule has you take the derivative of the inner part, and that would be 2 times 0.1 would be 0.2 times x, and drop the exponent by 1, make it a 1. There is your derivative. So if that's where you started with this thing, that would be a differential equation, and your efforts then is to find the function that makes that a true statement. So what we did in calculus 1 was take derivatives, and what we do in a differential equation is undoing those derivatives. And sometimes that's by integration, and then that's exactly how we would do it here, is do it by integration. Other times we can't use just plain integration, and by itself you have to have different techniques. So that's what we're dealing with here. Okay, so let's go back to the text. And like we just saw, dy dx was 0.2, I hope I had that, x e to the 0.1 x squared. Now, if you replaced e to the 0.1 x squared on the right hand side of this equation here, no, here, this part right here, that part right here, that was your y, right? So then you could have written this dy dx, that part there, is equal to 0.2x, that's that part right there, times y from up here. Now, that's something we can't quite do just by integration because you have x's and y's in the same term. But guess what? There are techniques for doing this. Okay? What if they said, what is the function is represented by that y? Okay? What you're doing now is solving an exponential equation. Okay? I mean a differential equation. Okay. How do you solve an equation such as this if you didn't know where you got it in the first place? Okay? Well, that's what we are. So here's your first definition. Okay, remember this is definitions and terminology. Here's your first definition. An equation that is made up of, like number 1 here, with a derivative of some order on one side is equal to some expression of the independent variable x and the dependent variable y on the other side. That's a differential equation. Okay, so here's a little bit more detailed definition. An equation containing the derivatives of one or more unknown functions or dependent variables. The function is your dependent variable, your y, okay? With respect to one or more independent variables, in this case we just had the x, that's your independent variable, one dependent variable y. But you could have more than that. That is said to be a differential equation. Okay, now we'll classify these differential equations 3 different ways. First is what type of equation it is. Second, what order the equation is. And thirdly, whether it's linear or not. Okay? Now, the type of equation will be either one of 2 things. So you're only going to have 2 choices there. The order could be whatever the maximum derivative in that is. Okay, so that could be a variety of numbers. Linearity, again, is going to be a binary thing. It's either linear or not linear. Okay, so let's start with the type. Okay, classification by type. A differential equation contains, if a differential equation contains only ordinary derivatives of one or more unknown functions with respect to a single independent variable, then that's called an ordinary differential equation. The book usually abbreviates that to be an ODE. That's not you're singing an ode to your girlfriend. That's just an ordinary differential equation. But an equation involving partial derivatives, and here's the disadvantage of your being in Cal 3 at the same time you're in differential equation. You haven't hit partial differentials yet, okay? And we won't hit them until later in the term. So I'll explain to you what we mean by that. I'll do a little bit of it. Well, I won't do much of it now because we've just run out of time. So this is where we're going to pick up next time, okay? We're going to pick up with classification by type. Somewhere here at one point I had me an eraser there. I found it. Okay, let me erase this and we will do classification by type. This is where we'll pick up on Wednesday. Okay. Okay, Wednesday. Okay. Any question on anything we've covered so far?
No.
Okay. Okay, I know, this is awfully slow. All right, and it was everything you just heard before. Okay, so we'll pick up and go from here, and no more blah, blah, blahing at the first, though there's plenty of blah, blah, blah here. We'll get it right into the text next time. Good deal. Yeah. Oh, are you in linear algebra also? All right, well, congratulations. Way to go. And that's 3 papers you'll have, okay? Right. But start knocking them out as early as you can. Okay. Get as many bonus points as you can so they don't all pile up at the end of the term. Okay. All right. Well, I'll see you tomorrow. Then what's that? About 11:30?
Yeah, around that time, I
Yeah.
think. I'm not really sure.
Okay. And that time I'll be really hungry because I will not have had time for lunch and I'll only have 30 minutes after the class to eat lunch. So it's even worse than my Mondays and Wednesdays. So I'll see you then tomorrow. Okay.
All right.
Good deal. So I'm going to first stop the sharing here and I'll end our recording. So take care. See you tomorrow.
All right. You too. Bye.
All right. Bye bye.